and they have to have certain restrictions placed on them to decide what you're allowed to execute and when. The two main ones that everyone is probably familiar with is the safer instantiation, which means the object is allowed to be instantiated from a persistent COM stream, which we'll talk about in a minute. And there's safer scripting, which is you can script the object from JavaScript or VB script or whatever. Now, recent versions of IE actually added more granular control over ActiveX. There's system-wide killbits, per user killbits, and you can also actually configure like white lists of websites or per domain or per user controls over which ActiveX controls can be executed in different contexts. And this is pretty good for policy management, I suppose. The last thing you've probably heard of is, of course, killbits, which is basically a mechanism that IE also has where when a ActiveX control is known to be dangerous to be run from an unsafe environment, they can set a registry key, and basically this ensures that that IE won't instantiate this object on behalf of the user. Now, ActiveX controls actually utilize COM quite extensively. ActiveX are scriptable objects, and they basically expose an iDispatch or iDispatchX COM interface. And this interface is basically self-publishing. You can find out the names of the functions and properties available. And you basically, whenever you want to actually call a method or access a property from that particular control, internally the iDispatch invoke function is called with an ID that identifies which property or method you want to access, and then it goes ahead and does whatever it needs to do. Now, the parameters passed to ActiveX controls are actually passed in a disparam structure, which you can see on the slide there. And the most important thing about this is essentially it's an array of variants. And these variants are the variables that it received as parameters from the scripting language or whatever. So these variant data structures are actually quite important because they're one of the key components of interoperability. They're basically used to represent different data types. You have it's a very simple data structure. It has a type variable which indicates what type of data is being contained in the variant, and it's got a union which contains the value of the variable. So you might have a type that says it's a string, and then the value will contain the relevant string of what the user supplied. Now, the type is actually not just an enumeration of numbers. They've got what's called a basic type, and you can see some of them listed in the table there. And these basic types have values from 0 to OXFFF. And these are the types you would expect to find, like integers, strings, dispatch objects, which are COM objects, Boolean, variant, and so on. But you can also have modifiers that modify what type of type is being held in the variant. And the modifiers are basically VT vector, VT array, and VT biref. If you've got the VT array bit set, basically it says instead of having the basic type being contained directly within this variant, the variant has a pointer to a safe array structure of that data type. So for example, you could have a variant that has the type VT array ORed with VT bool, and this will say that this variant contains a safe array data structure that points to an array of booleans. The other thing you can have is the VT biref modifier, which basically says this is a pointer to the basic type rather than being a literal value. So if you had a VT I4, for example, like an integer, and you ORed it with VT biref, then the value in the variant would have a pointer to an integer rather than just a literal integer itself. So when I talked before about safer instantiation, and basically that's all about COM serialization. So basically COM objects can be serialized into flat files and then resurrected at a later point in time. And they can do this by implementing one of a series of COM interfaces, and if they support this interface, they implement it, and then they mark themselves as safer instantiation, and then you can actually read a flat file, and it knows how to parse it into an object that's resident in memory. The relevant COM interfaces are the iPersist interfaces, basically. And in order to support serialization, the object just implements this functionality. So persist streams basically receive a pointer to a data stream, and they know how to parse it back into a COM object resident in memory. And the function responsible for doing this is the load method in the iPersist interface. Now, because everyone doesn't want to re-implement the same thing of resurrecting COM objects and so on, most people use an implementation of the load method that Microsoft provides in the ATL library called iPersist stream load. And basically what this allows them to do is define a property map where they just say, okay, I've got all these different types of properties, and they use some macros that are listed on the table there, and it will fill out data structures, those ATL prop map entry structures. And then basically the load method goes through, sees what properties it needs to load, and loads them one at a time from the file until the object's been completely unpacked. Now the interesting thing is that if an ActiveX object is safe for instantiation, you can actually embed these serialized COM objects in web pages themselves. And you can see an example of how to do that. Basically you specify the data parameter in an object tag, and you give it a URL to a file. And if this object that you're trying to instantiate supports COMs persist streams and is safe for instantiation, it will go ahead, read the data from that file, and try and unpack it into memory. So this is kind of an example of basically how it looks like. As in this particular case, you know, the programmer is just using the ATL functionality that I described before. So they just have these data, these prop data entry macros and stuff, where they just say, okay, I've got an integer, this is where you need to put it, I've got a name, etc. And basically you can see that this translates into a binary representation that you can host via the object tag. So that's a really brief primer on some of the technologies that we're going to be concerned with. We actually wrote a pretty in-depth paper about all this kind of stuff, so if you're interested in it, you'll probably find a lot more information in the paper that we wrote, which I'll give a URL to later. So if we're looking at the attack surface, there's quite a lot of stuff to attack. Firstly, there's the DOM implementation itself. The code that implements the DOM functionality, there's quite a lot of it. There's ActiveX controls, and I mean they've been targeted a lot in the past, but if you consider the safe for the instantiation, the iPersist stream stuff, that stuff's been targeted very, very little in the past. Most of it has been the scriptable interface that objects expose. You've got language runtimes themselves, both the native functionality and the marshalling code. And then you've got trust boundaries, which is basically when security mechanisms are implemented, where are the boundaries where they start trusting other objects, and we'll talk more about that a little later on. But we'll look at the DOM implementation first. So this is actually a really large code base, and it's implemented within ms.html.dll. It has to expose all the functions that you can call from the DOM are implemented natively in ms.html. All the marshalling code that basically takes input from anything that can interact with the DOM, whether it be JavaScript, VBScript, .NET, etc. It takes all that, it has to marshal it, do type resolution, and it has to be able to marshal the outputs as well. Now, an extensive amount of this functionality is reachable via scripting, so it's a very large attack surface. And basically, the DOM utilizes COM internally quite extensively, much like ActiveX, where they have a dispatch function used to access methods or parameters or etc. Now, what I found out when I was looking at the DOM for IE is that objects are actually published via a class descriptor. So every object that is available in the DOM actually extends from this C-base class, which is not externally COM visible. But each